Alrighty. So today we're going to get our last two transformations so we can see all the things that could possibly happen to one of these graphs. So yesterday we talked about A, which does our amplitude changes. That's where it's stretching or compressing vertically. And we did B, which was the period adjustments, where it changes how far it takes to go a whole sine. So it's a horizontal stretch or compression. Today we're going to touch on H and K. H and K we've seen a gabillion and a half times before since we first started working with quadratics. So H does our horizontal shift, K does our vertical shift. They do a couple of funky things, but that's still what they're going to do. Just simply because of some of those period changes, they're weird. So we're going to take a look at them. This is going to be our first one we're going to do. We're going to do sine of the quantity 2x minus pi over 2. So the first piece I want us to look at is we're going to find the new period length. So normally with sine, it goes from 0 to 2 pi, because that's how long it takes to go all the way around the circle, going right way around for y'all. So normally it takes 2 pi, but this b value, this guy in here, adjusts that. So to get the new period length, that's when we take our 2 pi, the whole cycle that we had, and we're going to divide it by that b. So in this case, it's going to be 2 pi over 2. So what's the length of the period for this function? Pi, bless you. So it's taking our whole thing that was 2 pi long, and it's going to squish it down all into 1 pi. Our A, we don't have anything multiplied out in front, so our A is going to be 1. So that means our amplitude isn't changed. We don't have any vertical stretch or compress. It's going to go up 1 and down 1 from the middle. The way we figure out kind of how we're going to be counting our x-axis is going to be with our period and our endpoints, just because that makes our life a lot easier. So to find our left endpoint, where we start, where we're going to put our very, very first point, I'm going to take this whole statement, my 2x minus pi over 2, and I want to know when that thing's going to be equal to 0. Because we normally start at angle 0. I want to know where angle 0 is for this. So we're going to take our, I zoomed in too far, there we go, our 2x minus pi over 2, and I want to know when that equals 0. What am I going to do here to try and figure that out? Add pi over 2. So we're going to have that our 2x is pi over 2. And what do? I want x by itself. Divide by 2. So we're going to get that x is what? It's pi over 2 divided by 2. Pi over 4? Pi over 4. So what that tells me is my very first point is going to be at pi over 4. And that my period length is pi. So from those two alone, we can usually get figuring out how to do our x-axis and how to number it well. But I'm going to do the right end point at the same time just because mentally it's weird if I don't. So to find my right end point, like we think through our circle, we normally start at 0 and we go all the way around until we get back to 2 pi. That's one whole cycle on sine. So to find my right end point where we normally end, we're going to do the same thing. We're going to look at our 2x minus pi over 2. But I want to know when that equals 2 pi because that's normally where sine ends, where we hit our first repetition. So it's a very similar vibe. We're going to add our pi over 2 to both sides to get that our 2x equals 4 pi over 2 plus pi over 2. So 5 pi over 2. Which means our right endpoint, it's okay, it's going to be at 5 pi over 4. I like calculating them separately like this because it lets us double check that I do in fact have a period length of pi. So we found that correctly. You can also take your left endpoint and add your period length. It'll get you to the same spot. What's up? So think through our unit circle. We started at 0, and we go all the way around our unit circle, and we normally end our unit circle at 2 pi, because that's one whole cycle through the circle. After that, it's just repeating. That's where we're getting our 0 and the 2 pi from. It's where we start and where we end on our circle.
That's what the
Mm-hmm. What that tells us is that tells us how big my sine function is going to be. So this one's going to be a little bit smaller than our parent function, but not that much smaller. So we can still count by the same amount. If you want to count by a different amount, that's totally fine. For our x's, I'm going to count the same way we did yesterday, just so that they all kind of look the same, and we can see really what's happening with the transformations. But this is where we can figure out if we need to count by something else. So if we have weird units, if our period length is really, really big, we need to be able to make sure we can fit 2 whole periods on the graph. That is one of the things we have to have when we're graphing it. So since the period is smaller, it's not that big a deal. We will definitely get that far. So we're going to have our pi over 4, pi over 2, 3 pi over 4, and pi. So I'm counting the same way as yesterday, where I get 4 spaces to a pi. So this one's 2 pi right there. Okay. And 1, 2, 3, 4, negative pi minus 2 pi. So just like that, same counting we had before. We're going to put our left endpoint, which is going to be right on our x-axis, because we do not have any other shifting going on. We start at pi over 4. And we know we're going to end at 5 pi over 4, which is right here. All right, I am going to put the faintest ghost of the sine function up here just so we can see what normally happens. Because normally, sine looks like this. You don't need to draw this on yours. That was terrible. Oh my gosh. This is just so we can see it. I am almost never going to draw sine and a transform sine on the same graph because it just looks like a 5-year-old got your paper and scribbled all over it. So I'm just putting it up here so we can see it. Normally, sine goes up to 1, back to 0, down to 1, back to 0. And it's a very regular pattern. Like on this one, it was 0, skip 1, skip 0, skip 1, negative 1, skip 0, right? 0 is halfway between. So I know if I know the left end and the right end, halfway between, we're going to have another 0, right? So I can get another point just from that alone, from knowing that cycle. And that sine, we start going up. So it's going to go up to 1, back to the 0, down to 1, back to 0. Because our amplitude is that 1, it's not changing height. So we have to know the pattern to be able to spot it. So it's going to go up to 1, back to 0, down to negative 1, back to 0. And that's one of our sine cycles. And it fits in that period length of pi. We have to go up and down in that length. From there, it's just repeat the cycle. So we're going to go up to 1, back to 0, down to 1, back to 0. As long as we get 2 period lengths, we're good. I have a tendency to fill the graph in just because it feels wrong if I don't. But it's going to look kind of like that. Normally, we do not have the little sign underneath it. I just had that so that we could see what sine normally looks like. So we can see very much that it has been compressed. It's been shifted to the right, pi over 2. Or shifted to the right, pi over 4, excuse me. And the amplitude did not change. The period shows us how wide one sine is. So how we started here at the pi over 4 and we ended here at the 5 pi over 4, That means we have to go up and down in that length. You can also get your period length from the right minus the left. You can get your right endpoint from the period plus the left. These things all interact together, so there's many ways to do it. I just feel like this is one of those familiar concepts. Yes, my dear.
We're just gonna have to like mark it in the graph, the period. Like the little.
I'm thinking. You don't have to draw it on the graph like this guy up here. We will need to find it because there will be times when we count by different units because of how long our period is. But for the most part, no. You can put it in the bin still. I have my second periods in there. Thank you, dear. And then if you bring me the pass, I'll sign it for you again so you can go back. Okay. So what's our domain for this one? Negative infinity, positive infinity. Our domain is negative infinity to positive infinity. And that is true for sine and cosine, for sharesies. Because they don't have any undefined values. If we can go all the way around that circle as many times as we want, and I don't ever get anything undefined. What is my range on this one? -1 to 1. We always write it smallest to biggest. It can equal both -1 and 1, so they both get brackets. The range will change based on what kind of shifts we have, whether it's amplitude changes, vertical shifts, things like that. The domain for sine and cosine are always going to be negative infinity, positive infinity. Because I can go around that circle however many darn times I please. Just sit and spin. Forever and ever. Out to infinity. Okay, so the H transformation really plays with our left and right endpoints. We have one more transformation to see. And that's all the things we can do to these. Okay, so our last piece is we're going to look at that K and what that's going to do with our vertical shifts and how we do that. This will be our last one for today. It's got a few other things in it. It's not just one thing. Always practice more than one thing at a time. It's that. But we've got 2 sine of the quantity x minus pi over 4 plus 1. And it's going to feel a little bit backwards because what we're going to actually do, our very, very first thing, is the K transformation. I want to know where we start before I start doing any other point so I don't have to move absolutely everything else. So on this guy, we have a plus 1. It means my whole sign is going to shift up 1 because that's what K does. So I'm going to draw a middle line. I'm going to put the midline on here. We don't typically draw the midline mostly because it's on our x-axis. And a lot of times, and especially on my answer keys, I tend to draw them as dashed lines. I want to be able to show it to you without the midline on there, so I'm going to draw it solid. I genuinely do not care if you draw it solid or dashed. Just don't draw it like dark, because you'll get your x-axis and your midline mixed up in your heads if you draw them really, really dark. So dotted or not, I don't care, just do it light. Because we need to go up 1, so all of my zeros are on this. This is my midline. That's what we call it. Again, it's not a humongo deal, but it is where we're going to plot all of those zeros that we find. Our left endpoint, our right endpoint, the zero that's in the middle, they go on the midline. Everything after that is identical to what we just did on the previous ones. We're going to find our period, which we take the normal cycle around the circle, which is 2 pi, and we divide it by b, which would be the number in front of the x that's inside. So 2 pi divided by b. Our b in this case is 1, so the period length is just going to be 2 pi. There's no change to it. We do have an h, so we got to find that endpoint. Our left endpoint we get when that whole statement equals 0. So when this guy, our x minus pi over, I have no idea what was 4, equals 0. So we're going to add pi over 4 to both sides to get pi over 4. Our right endpoint we get when that whole thing, that x minus pi over 4, gets all the way around the circle. So when that normally equals 2 pi. So our right endpoint is going to be at that 9 pi over 4. There we go. So I know I need to be able to fit 2 whole periods. I'm starting at pi over 4 and ending at 9 pi over 4. If I count the way we've been before, I will still fit all the pieces in here. So find the period length and your endpoints before you number your x-axis. It'll make things way easier to deal with. So I'm going to do the same thing and use 4 units to a pi. So 1, 2, 3, 4 pi. 1, 2, 3, 4, 2 pi. 1, 2, 3, 4. Minus pi. Minus 2 pi. And if you just number those pieces, that's plenty of information to see. But we'll get our left endpoint at pi over 4 on the midline up here. And our right endpoint is at 9 pi over 4, which is on the midline. Looking at sine, we have another 0 at the halfway, at the midpoint, halfway through that. So exactly between pi over 4 and 9 pi over 4 is right there. We're always going to have another 0 in between. The last piece on this is our amplitude, because we do have one of those changes. So our amplitude out in front is that 2, and all that means is instead of going up 1, it goes up 2. So in between the 2 zeros, when we get to that top, which we normally went up to 1, it's going to go up 2 units from the midline. This one's going to go down 2 units from the middle line. So if we look at our sine here, it's going to be up 2, back to 0, down 2, back to 0. And that's our 1 unit of pi. Sine. I'm good at words. That's 1 unit of sine. So again, on our graphs, we need to have 2 full periods. This will continue up that way, but I can't fit another one, so we're going to go skip 1 down to 2, skip 1 back to 0, skip 1 up to... I was right at the end there, but that is all the things we can do. Tomorrow we're going to play with cosine, but it's not any different. I will get the graph finished and put up on Canvas for our notes so we have them. Have a great rest of your day. We will look at cosine, which does almost identical things.